A very good afternoon to all the participants. This is Mahavir Pinna, Assistant Professor, Department of Electronics and Communication Engineering, Sri Venkateshwara College of Engineering, Bangalore, Karnataka. We welcome you all for the third day of the AICTE sponsored short-term training program under AQIS program on optimization techniques for 5G cellular networks from 13th to 18th July 2020, organized by Department of E&CE, SVCE, Bengaluru. In day one, we had two sessions by keynote speakers, Dr. Suresha Sir, Principal, SVCE Bengaluru, and Dr. Dilip Reddy Sir, Associate Professor, Department of E&CE, SVCE Bengaluru. They highlighted on the introduction and integration of 5G with the IoT technologies. On day two, we got extensive knowledge on technology driving 5G and optimization using artificial intelligence and machine learning by Dr. M.H. Kori Sir from IETE, followed by Dr. J.J. Sir session on emerging research opportunities in 5G wireless networks. Today, in the morning session, we gained a lot of information from Professor Muhammad Kurram Sir on 5G wireless communication security. Now, we are very eager to listen to Dr. Poornima Madam, Professor, Department of E&CE, SVCE, Bengaluru. Ma'am is going to give her presentation on evaluation and future scope of 5G technology. On behalf of management, principal, and head of the Department of Electronics and Communication Engineering, SVCE, we welcome you, madam, for this event. I would like to introduce the session speaker to the participants with a brief profile. Dr. Poornima Madam, working at Sri Venkateshwara College of Engineering as a professor in Electronics and Communication Department. She is serving the institute since 2001 with complete dedication and commitment. She gained her doctoral degree in the field of VLSI from VTU Belgavi. She had published over 70 publications in various peer-reviewed journals and conferences. She is the active coordinator for NBA and NACT activities of the institute and the department. She has received various funds from various prestigious organizations like DST and KCST. She guided many of the students in product development and patent filing. Her area of the interest include VLSI, digital systems, artificial intelligence, machine learning, and embedded systems. She is also the member of several professional bodies like IEEE, IETE, ISTE, and many more. She also handled several practical hands-on workshops, faculty development programs at various colleges of the country as a resources person. We are greatly honored and privileged to have you with us for this elite event, madam. With this introduction, I once again welcome madam and request madam to take over the session. Welcome, madam.
Thank you, sir. Thank you, Mahavir sir, for your nice introduction. So let us continue with our presentation. Mahavir sir, are you able to see the screen?
Yes.
Mahavir sir.
Yes, madam. Yes, we can see you, madam. We can see your screen.
Yes. Yes.
Thank you.
Thank you, sir. Thank you. Good afternoon, all participants. First, I would like to thank my HOD sir, giving me an opportunity to give a topic presentation in this 5G or wireless technology. Myself, Poornima, Professor in Electronics and Communication Engineering Department. Today, I would like to take up a session based on the topic. It is evolution and future of 5G technology. The contents of my presentation I have planned as follows. Initially, to start with, I'll be going with introduction, Next, I'll be explaining you what are the different types of device communications which are established. Then the key motivational factor for 5G technology, it is the wireless communication. And the next topic I'll be discussing is on wireless system evolution in detail from first generation wireless systems to fifth generation wireless systems. And then I'll be discussing the wireless networks, different types of wireless networks which can be used, and what are the future 5G applications, which are the various research domains where, as a research student or in future, we can focus. So these are the key contents I'll be discussing in this presentation. To start with, let me give an introduction. Even though there are many in the wireless industry or in the communication field, many industries were working, but the major industry which is playing a key role in telecommunication in the communication field is the telecommunication industry. The reason behind this telecommunication industry became the key responsible organization. The reasons are listed here. Telecommunication industries are the key factors of financial and community development or societal development of a nation. And they are increasing the efficiency of profitable and organizational activities. Telecommunication industries improves the effectiveness of social and emergency services as and when it is required by deploying advanced devices. The telecommunication industries are the key role factors to distribute the social and cultural and economical benefits. They provide universal service for rural and remote communities. These telecommunication industries, even though they started working since from the way back 1920s, but from the telecommunication industries, the mobile wireless communication came into enforcement from 1980s onwards. But early to 1970s, the wireless technology was in creation and revolution. It made a revolution. But the evolution, as I told you, it started in the year of 1980s. In 1980s, the telecommunication industries introduced first commercial mobile phone. When from 1980s, during 1980s, these mobile phones came into the market. The users of these mobile phones drastically, tremendously increased. And this increase in the user, it was in an exponential manner. So therefore, the telecommunication industries, they found that there is a lot of demand for these wireless devices. These telecommunication industries, after they introduced these mobile phones, they have gone through the survey and they found that by 2020, the number of users these mobile wireless devices, including smartphones, have been increased 63 million. And by 2018, the same telecommunication industries, they estimated that 238 million users may worldwide. Out of worldwide, it was estimated 4.5 million mobile phone users by the same industries. And out of these 4.5 billion mobile phones, they expected that 2.5 billion mobile phones are wireless devices, maybe of smartphone, and there will be of smartphone users. This gave an motivation for and resulted in demand for rapidly increasing increase of mobile data. As the number of mobile users have been increased in the telecommunication wireless sector, the demands from the users have also been increased in terms of their applications. So this has led to the drastic development in the evolution of the wireless technology or wireless systems. So before we go for these wireless technologies in detail, what are the various types of communications which we'll come across in our daily lives? All the device communications have been classified into 4 different categories. The first one, fixed and wired device communication. In this, fixed device will be using communication, will be using to communicate with the another fixed device. When an example it is considered, it is a desktop which will be using the fixed network. Another type of communication device which you will come across in your daily life is mobile and wired. So there will be the combination of mobile devices as well as the wired communications. One such example is the laptop. Laptop, even though it is a mobile device, when it has to be connected to the telephone, through the modem, it comes under mobile and wired device communications. The third category of device communications, it is fixed and wireless. Here, the building will be fixed. Within the building, through the wireless, a communication will be established that you can consider as an example for fixed and wireless wireless device communications. The last category of wireless device communications in general, it is mobile and wireless communication. Here, both the user will be in mobile condition as well as they'll be device to device communication. It will be done through wireless. So since there is an demand started in the telecommunication industries from the customers or from the users, the telecommunication industries, they have gone through an drastic research in the frequency spectrum also. And the researchers, they have found that the frequency spectra which is supporting for these wireless communications are the radio frequency waves as well as the IR waves. So then they start deployed these wireless devices. So wireless communication between any two devices to establish, there won't be, as we know, the communication will be without wires. And how do then the communication will be established between the two devices? Through wireless, it is wires are replaced by electromagnetic waves. The electromagnetic waves will carry a signal through atmospheric space. And this is the frequency spectra. From this frequency spectra, two different categories of frequencies have been considered. One is the RF frequency and the other one is the IR frequency. RF frequency, it is from 30 kilohertz to 300 gigahertz. All these frequencies are used for the wireless communication. Similarly, the IR band of frequencies starting from 3 terahertz to 430 terahertz also have been used for these wireless communications. Once these frequencies have been selected and the devices have been deployed, the mobility aspects are considered. When the mobilities are considered, the mobility of two types. One is the device portability, and there is another type of mobility you will come across is the user mobility. When there is no mobility, the user or the device, mobile wireless user using same access point. When there is no mobility, the user will be using the same access point. But as the movement of the wireless user starts, there will be a connectivity as well as disconnectivity for the network. And if there is a high mobility, the user will be passing the multiple access points while maintaining ongoing connections, because these are the actual needs or actual factors which are affecting the mobile communication or wireless communication. And these are the key factors which can be considered for the future research in terms of the ever long lasting connectivity, even though there is an less mobility or medium mobility or high mobility of an user. So these mobilities have been graded into two different categories: walking users mobility and the vehicle mobility. When the walking users mobility has been considered, the factors which are considered by telecommunication industry to provide low speeds, and the walking users will be using small roaming areas, and the walking users will be usually uses high bandwidth. When the vehicular mobility is considered, usually the vehicles will be moving with fast high speeds, and they'll be covering a large roaming area and uses lesser bandwidth, and they must use sophisticated terminal equipment. So these are the various mobile wireless devices which in our daily lives we'll come across, and these devices have been categorized based on what. So that is what I'll be discussing from now onwards. But before we go for that, who are the stakeholders in these wireless devices? There are regulatory authorities who are the major stakeholders for the wireless devices and wireless networks to establish. The operators are the service providers, the users are the subscribers, the ultimately the user, and it is supported by the entire wireless network or device communication. It is supported by various research organizations. Now let us see what are the various wireless systems, how they have been evolved. In 1980s, when the first mobile came into mobile phone existed in the world, the first mobile phone, it is categorized as first generation communication wireless device or wireless systems. What are the various key features of these first generation wireless devices? First, it was introduced in 1980s. We know it is deployed for wireless telephone industries, for mobile telecommunications, and speed of that mobile, it is up to 2.4 kilobits per second. The first generation device has allowed only the voice calls, and that too within any and the type of signal that has been used for in the communication, it is of analog signal, and the multiplexing system, it is an frequency division multiple access multiplexing system. The frequency band that is used by first generation communication wireless devices, it is in the range of 450 to 900 megahertz. The capacity offered by this first generation device, it is of very less because its data rate it is lesser than 10 kilobits per second. When the architecture of this first generation wireless communication devices are considered, how it has been deployed by the telecommunication industry, it is as follows. Entire geographical area has been divided into cells, and each cell used to be placed with an antenna, and each cell used to be with frequency, and that architecture used to have a base you will have a base station which does transmission, reception, and controls all the communications. In the first generation architecture, because it is based on cell concept, adjacent cells will be assigned with different frequencies to avoid the crosstalks. In the first generation communication wireless network systems, will have the mobile switching center. This mobile switching system will have a responsibility of controlling the calls from various devices, maintaining the billing information, and switching all the calls. It includes even the public switch telephone network also. This will have an access for all the cells, mobile switching center, and all the user connectivities. To see this frequency division multiple access cellular architecture of first generation devices, this is how it looks. A entire area has been divided into cells, and each cell will be assigned with a single frequency, and neighboring cells, when it is compared, it will be assigned with the different frequencies, so which will avoid these different frequencies will avoid the crosstalks. And how this complete infrastructure it has been established in 1G, it is there is a mobile phone, base station, mobile switching center, and the PSTN, that is public switch telephone network. The first generation devices, wireless devices, are when they came into the market, there are standards, wireless standards, which are supported. These standards includes AMPS. It is the Advanced Mobile Phone System. It is designed and developed by AT&T Bell Labs in 1970s, but they deployed in 1983. This wireless standard, it supports a channel bandwidth of 30 kilohertz, and the number of users, because of the limited channel bandwidth, it was also limited. Including South America, China, and Australia, they have deployed this AMPS standard. Apart from that, other countries they used ETACS, that is European Total Access Communication Systems, where the channel bandwidth has been scaled to 25 kilohertz instead of 30 kilohertz, as in AMPS. This is an advancement in ETACS. Because of this, the number of users slightly they have seen that they can increase. What are the various drawbacks of these first generation wireless devices? After the first generation devices came into the market, users they have used, and from the user side, they have found few drawbacks. The first drawback is poor voice quality, the poor battery life, large phone size, no security, limited capacity, poor handoff reliability. These factors motivated again telecommunication industries to think further beyond these devices, the research to start. So hence they have gone for second generation wireless systems. These second generation wireless systems are also called as 2G wireless communication. It is global system for mobile communication based. So the 2G second generation mobile communication devices based on GSM, launched in 1990s for the first time in Finland, and the second generation mobile devices have used all digital signals. The type of multiple access, it is time division multiple access as well as code division multiple access for spectrum sharing used. There is a circuit switching technique has been adopted in second generation wireless networks. It has provided a better quality and capacity because of this GSM and TDMA with the CDMA. Nearly 3 times they have seen that there is a better quality and capacity. But the frequency band from first generation to the second generation has been changed from 900 to 1800 megahertz. The data speed, it has been increased to 64 kilobits per second. These are the various key features of this second generation. So the other important feature of this second generation, these second generation devices, wireless devices, supports only voice-centric services. These voice-centric services limited to text messages, picture messages, and multimedia messages, MMS, and fax, that is facsimile. These are the limitations from the second generation. When the second generation it has been devices have been deployed, there are few standards. It is a GSM. This GSM, it is based on TDMA, serves as the European Cellular Service, provides wide range of network services, including phone service, fax, SMS. Supports 24.7 bits per second data rate. The another standard, it is United States Digital Cellular. It is USDC. It is also a TDMA system similar to AMPS, but supports more users, which are 6 times more compared to AMPS. Provides access to virtual VPN networks and also supports short messages. The data rate in this standard, it has been increased to 48.6 kilobits per second. The third standard in the 2G wireless communication systems is IS-95, United States Digital Cellular Standard. It is purely based on a CDMA technology, compatible with AMPS first generation also, and uses CDMA, dual mode phones, and base stations. Okay, that is an added advantage with this standard. The capacity wise, that this IS-95 standard, it has supported 8 to 10 times more compared to AMPS. It supports 14.4 kilobits per second data rate. When the architecture of this 2G is considered, there will be an base transceiver station to which the different mobile users will be communicating, and there will be base station control for the switching action, and there will be a mobile switching center from cell to cell connectivity, and there is a mobile switching center which will be connecting to the public telephone network. And the devices, if you are considering in the 2G, a picture depicts these are the devices which are seen with the 2G technology. After the deployment of 2G technology based wireless devices, the challenges faced by telecommunication industry are the 2G devices have been limited to voice communications only. These devices, even though they are using digital transformation or digital signals, the digital signal strength should be very strong, which such strong signals only will help the 2G systems to work. That is a drawback that they have faced. And they have seen that if there is no network coverage in a specific area, the digital signals used to be very weak. And with the increase in the data rates, as the so overcome these disadvantages are the drawbacks with the 2G technology wireless systems. 2.5G technology deployed by telecommunication industries. It is the technology, it is about, its features are about to 2G, but the features are lesser than third generation mobile telephones. Compared to 2G, 2.5G provides high-speed data communication and continuous this is added fully digital having less than 50%. The 5G technology from GSM, they moved to GPRS, analog AMPS to CDPD. The 2.5G features includes we can make phone calls, transmit, receive emails, browsing we can do, speed, the limited to 64 to 144 kilobits per second. But it is a slightly good data speed compared to the 2G. MP3 song, which is of 3 minutes, it used to download 6 to 9 minutes. In 2.5G, there are few standards, that is CDPD, Cellular Digital Packet Data. A data service for first and second generation US cellular systems without any additional bandwidth requirement. That is a feature of this CDP, that is Cellular Digital Packet Data. Packet channels are dynamically assigned to idle voice channels is a feature of this CDPD. This CDPD supports 48.6 kilobits per second, as in IS 136. That is a standard that you have seen with the 2G. 2.5G is GPRS, that is General Packet Radio Service. Based on GSM, by allowing multiple spots of a GSM, radio channel be dedicated to a individual user, promises data rate from 56 kilobits per second to 114 kilobits per second. With this GPRS, continuous connection to the internet for mobile phone and computer users, easy to access VPN, also it is possible. 384 kilobits per second data rate with an improved modulation techniques and relaxed error control. Also, these edge standard is also referred as EGPRS, that is Enhanced GPRS. The next standard is CMA as S95B. It is providing a high-speed data access in a CDMA using a CDMA technology by directing multiple orthogonal user channels for specific users or specific purposes. This CDMA1 or IS95B, it supports up to 115.2 kilobits per second as the data rate. When 2.5G networks are considered, there will be voice associated with the data transmission. But XS GGSN, GGRS, GGSN, that is Gateway General Purpose. The general GPRS, that is Gateway GPRS Support Node, is GGSN. So these are the when voice and data started communicating. They found that with these standards, limited bandwidth, limited data rate, as third generation mobile devices. Introduced in 2000s, but before when the aim in simultaneous transmission of both voice and data, faster internet access, multimedia content, both voice, data, and video, universal global roaming. This is an expectation when the third generation devices they started developing. After the development of the third generation wireless devices or mobile devices, the key features they have seen with these 3G technology-based wireless devices are as follows. They provide faster communication. They're able to send, receive large email messages, supports high-speed web, more security, video conferencing. It supports even 3D gaming also. The other features includes TV streaming, mobile TV, phone calls, large capacities and broadband capacities. And they have seen a drastic improvement in the downloading and uploading, 11 seconds to 1.5 minutes time to download a 3-minute MP3 song. The examples of this 3G technology, 3G phones includes Apple iPhone, LG KF750, Nokia 5800 series, BlackBerry Bold 9000. These are the various devices which are working under 3G technology. So when you look at in simple, the evolution of this 3G to 3G from 2G, 2G started with CDMA, GSM, TDMA, 2.5G with GPRS, wideband CDMA, and along with UWC 136 standard, 3G. In 3G, these are the following features: CDMA, FDD, that is frequency division duplexing, then time division duplexing, H, and 136 high-speed outdoor as well as high-speed indoor applications. Some of these standards related to this 3G wireless communication systems are UMTS, that is Universal Supporting for 3G Wireless Systems, are UMTS, Universal Mobile Telecommunication System. The third generation partnership project. It is under this UMTS has been developed under 3GPP. It is an company which under which many sub companies have been contributed. They have made a standard. That is what 3GPP. A wideband CDMA they have used, which used to support up to 5 megahertz, and the fundamentals of GSM or Edge is designed to provide backward capability with the GSM, IS-936, GPRS, and Edge. These are the various features of this standard. Backward capability means it's used to support for 2G, 2.5G. Can support this 3G, this UMTS will support up to 2 megabits per second, and it new RF equipment, it is needed, like a antenna, it is required for these devices to work. The next standard under 3G, it is CDMA 2000. It is third generation partnership project to use the same bandwidth as IS-95, adjacent 1.25 megahertz channel, 3 times bandwidth as that of IS-95. Is a feature of this 3GPP2 or CDMA 2000. It was deployed in the year of 2000. This CDMA provides instantaneous packet data access at 144 kilobits per second or 2 megabits per second. Here, when CDMA standard is used, additional RF equipment is not required. Changes are made in both software or baseband hardware only. So that is the reason RF equipment, it is not used in CDMA. This is another standard. Coming to the fourth standard under 3G wireless systems, TD-SCDMA, that is time division synchronous CDMA. It is a standard proposed by Khan Academy and Telecommunications Technology and Siemens Corporation. This standard relies on GSM infrastructure and allows 3G data access by handling high data at each GSM stations. Supports up to 384 kilobits per second of packet data. These are the various 3G third generation devices which will be in the market, which are used in the market, which are deployed in the market by telecommunication industries. Drawbacks of this 3G technology. The expensive 3G licensing is the main setback for this 3G to think for technology. The infrastructure to build, it is a challenging task. The bandwidth requirement, it is very high. And the cost-wise, when these mobiles are considered, it is expensive. And size of these cell phones are very large. To overcome these drawbacks of 3G, the 4G technology, 4G wireless devices have been revolutionized or researched. The key features of high-speed data. It is very high-speed data, high-quality streaming video combination of Wi-Fi and WiMAX, able to provide up to 100 megabits per second to 1 gigabits per second speed through this Wi-Fi and WiMAX. This 4G technology based wireless systems, in short, it can be described as a magic with a single acronym, magic. What this magic is: mobile multimedia, anytime, anywhere, global mobility support, integrated wireless solution, customized personal service. It is also known as mobile broadband everywhere. The 4G technology applications includes web access, IP telephony, gaming services, high definition TV, video conferencing, and 3D television. Some of the standards under 4G are WiMAX, LTE systems. LTE systems, first deployed in 2011 by Australian government, used to have the speed of 2 to 40 megabits per second. In India, Bharati Airtel has launched 4G service using TD-LTE technology in Kolkata in April 2012. This 4G, anytime, anywhere, technology wireless standards. Other features includes capable to provide speed from 100 megabits per to 1 gigabits per second, high quality of services and high security provision for any kind of service at any and anywhere. That is the reason why it is termed to be anywhere, anytime. More security, high speed, high capacity, low cost per bit transmission. Even this 4G has limited in its working. The various limitations are the
Madam?
various challenges for the fifth
Poornima,
generation devices to develop
Hello, madam.
are as follows. Battery use more. Fourth generation devices, when they are used, the battery use is more.
Poornima, madam?
Difficult to implement, requires complicated hardware, expensive equipment required to implement next generation.
Sorry for the disturbance caused due to some network issues. Just madam has been logged out. Please bear with us just for 2 minutes. Madam will be back.
You can deploy. Basically, these networks are, it may be the PAN, it may be the LAN,
Madam?
wide area network, or hidden area network, local area network, or personal area network.
Poornima, madam?
The personal area network will be supported by Bluetooth, 802.15 infrared RFID. LAN is supported by 802.11d, 802.11. These are the IEEE standards.
Hello, madam.
Metropolitan area networks have been supported by 802.11b or A, 802.16. And your wide area networks have been supported by GSM, GPRS, EPRS, UMTS, 3G. So the personal area network to develop requires low cost, very short distances. This personal area network will be supporting lesser than 1 megabits per second is data rate. But the LAN, when it is considered medium cost for deployment, distance, it is in terms of kilometers, from 2 to 54 plus megabits per second. And when
Sorry for the disruptions again. Yes, sir, we will resolve it. We highly appreciate our participants for bearing with us because of these network issues.
It covers long distances for any two mobile devices to communicate. It supports 10 to 384 kilobits per second data rates, and this wide area network will support fully mobile device, ubiquitous, high security, and easy to use. When the wireless personal area networks are considered, it is supported by RFID, very short distance range, 10 meters, sensor technology used to supplement barcode reader type.
So again, sorry for the disturbance. Madam?
Ravi sir?
Yes, ma'am. Ma'am, we are not able to see your PPTs, ma'am. Kindly once check, ma'am. PPTs. PPTs are not visible, madam. Madam, can you hear me, madam?
ಹಲೋ ಮೇಡಮ್, ರವಿ ಕೇಳಿಸ್ತಾ ಇದೆನಾ?
Yes, sir.
ಮೇಡಮ್ ಈಗ ಲಾಗಿನ್ ಆಗಬೇಕು ಅಂತ ಹೇಳಬೇಕು, ಲಾಗಿನ್.
Sure, sir.
ನಾನು ಇನ್ಫಾರ್ಮ್ ಮಾಡ್ತೀನಿ, ವೇಟ್ ಮಾಡಿ.
Sure, sir. So we really sorry for the inconvenience caused. Just a few minutes back, again, madam will join. I just want to remind our participants for the tomorrow sessions. Again, we have a two session. In the morning session, Dr. Shivashankar sir the Professor and Head Department of Electronics and Communication sir will be handling the session. And in the afternoon session, we have a Professor Santosh Kumar K, Assistant Professor, Department of E&CE SVCE will be handling this session. So we request all the participants, please join for the tomorrow session also. We will be sending the reminding mail in the morning also, the link and all. And I request all the participants kindly subscribe to our YouTube channel so that you'll get a notification. Yes, madam is back, I think. Madam, can you hear us? Poornima madam? Yes, ma'am. We can hear you,
Sir,
madam.
yes, sir.
You please load the PPTs once again, ma'am. And we would like to thank all the participants for the registrations for this event. I think 600 participants has been registered, and we also got positive feedbacks from you all. So from the management and from the principal sir and from the head of the Department of Electronics and Communication, we would like to thanks. And regarding the feedback, at every end of the session, we will be posting the feedback. So I request all the fill that Google form for each session. Yes, Mavish sir. Mahavir sir. Yes, madam. Can you hear me, madam? Ma'am, I think your audio is muted, ma'am. Please check it with once. Poornima, madam.
Sir, are you able to see the slides, sir?
No, ma'am.
No, sir. Yes, sir. Yes, sir. Sir, now? Is it audible,
Just
sir?
yes, we can hear you, madam, but slides are not visible, ma'am.
Sir?
Madam, can you hear, madam? Poornima, madam.
Sir, net is very slow, sir.
Yes, madam. I think, ma'am, that is the problem.
Yes, sir. Yes, sir. Now?
Yes, ma'am.
Sir, now is it visible?
Ma'am, I think you share it, madam.
Yeah. So, noted. Infrared range of frequencies, short range, usually line of sight, non-RF technology, used mostly for wireless remote control or wire replacement applications. These personal area. Sir, I have shared the PPT, sir.
Yes, ma'am. We can able to share view the PPT, ma'am.
Now, sir.
Just wait a minute, ma'am.
Yes, sir.
Ma'am, window, I think you just check it out, madam. The PPT window, I think you have shared the screen, ma'am, now. Yes, ma'am, we can
Yes,
able
sir.
to see,
Now?
ma'am. Yes, ma'am. Please make it full screen, ma'am.
Yes, sir. And
Thank you, ma'am.
the personal area network. Yes, sir. RFID, 10 meters distance. Infrared also it is supported in the personal area networks. Zigbee up to 10 meters. Operates in the range from 868 to 918 kilohertz and 2.4 gigahertz bands using 802.15.4 band standards. So another standard is a LAN standard. It is 802X wireless LAN. Networks, short range wireless communications, wireless fidelity is there, highly utilized and very popular. This LAN network, it is used for offices, airports, coffee shops, universities and schools. In LAN with Wi-Fi, two types of operations you can see. One is ad hoc networking, another one is access point. The next standard, type of network, it is a wireless MAN standard. It is based on IEEE 802.16 standard. WiMAX with the high cost. It will support from medium to long distance 22 megabits per second is the data rate through this MAN networks. LMDS, local multi-point distribution services also this MAN networks will support. Multi-channel, multi-point distribution services also these MAN networks will support. So coming to the last generation of the present generation of this wireless communication devices is the 5th generation. 5G technology refers to short name of 5th generation, which started in late 2010s. Complete wireless communication with almost no limitation. It is highly supportable to wireless World Wide Web. What are the key benefits of this 5G technology? It supports high speed, high capacity, and providing broadcasting data up to gigabits per second. It supports for multimedia, newspaper, watching TV programs with a clarity as that of high definition quality. Faster data transmissions, you can see with compared with the previous generations. It has a large phone memory, very high dialing speed, clarity in audio and video. It supports interactive multimedia, voice, streaming video, internet, and other 5G is more effective and more attractive. The 5G technology wireless solution, it is towards business and industry, schools and colleges, doctors and pilots, police and vehicles, etc. What is the feature of this 5G wireless systems? As more information becomes digitized, public and private sectors are undergoing tremendous change, and this change is resulting in the rapid development of mobile broadband networks and Internet of Things. It is expected by 2025 there will be 100 billion connections worldwide between people, things, and organizations. According to a white paper released by Forbes, 80% of the executives believe that 5G, a new generation of mobile broadband network, has a potential to provide the range of benefits. The industrial managers, they started realizing that this mobile broadband networks provide a path and platform for the upgrade and transformation of multiple aspects of their operations. This MBB and MBB network, mobile broadband network based on 5G infrastructure, will improve people's communication experience and also will be able to drive the production. It will driving force for change in production and operating systems through the connections between things and people, between people and things. This 5G mainly supports for different diversified applications. 5 such diversified applications of 5G wireless mobile broadband services are in the 5 major areas that have a significant influence on socio-economic infrastructure and people livelihood. The 5 different diversified fields are enhanced mobile broadband services. It is supporting smart driving, smart grid, mobile health, and smart manufacturing. These are the different domains these 5G wireless networks, due to the mobile broadband systems, it is supporting. What is this enhanced mobile broadband? 5G applications. Mobile video traffic increases rapidly through this, providing high definition mobile video anytime, anywhere requires higher network throughput and capacity. Applications are migrating to the cloud as mobile office applications, interactive, entertainment, and games are deployed on cloud servers. Network air interface performance to ensure the high speed and reliability of data transmission. The 5G future applications, both virtual reality and augmented reality applications in the 5G technology is the basis. It is based on the high definition video development and support. This virtual reality provides immersive user experience by creating a virtual world or simulating the real world, making use of sensors built into a handset to provide the interactivity with the virtual world. Augmented reality is based on the real world but offers more comprehensive perception of it by overlapping data. A wireless, other features of this 5G includes a wireless, untethered, immersive experience, enables people to watch movies and live sports programs, play games, shop online, and work remotely anytime, anywhere with convenience, freedom, and efficiency. Such services also enhance cooperation and interaction in fields like education, training, construction, city planning, and oil field explorations. What are the enhanced mobile broadband wireless communication devices requirements? It requires large bandwidth, low latency for real time, high quality image processing and spatial locations, HD image processing, scene identification and reconstruction, three-dimensional audio dynamic tracking and gesture dynamic tracing are needed. In addition, mobile terminals must have low power consumption. These are the various requirements of these enhanced mobile broadband networks. The network must help to enable low energy design. Network throughput, latency, and system capacity need to be improved. And network architecture, these are the various feature research topics which will be published in 2019 by Forbes. Speed in hotspots, the 5G mobile network must provide throughput of gigabits per second to ensure fully immersive wireless experience. In fast moving vehicles, the video streams of AR for video, intelligent navigation, and other non vehicle mobile broadband applications. Bandwidth requires up to 100 megabits per second. The another major field where the 5G devices will be used is smart grids. So this digital key drivers, why the smart grids also they are going for these 5G technology based this 5G technology based products. Digital transformation is challenging existing electricity generation facilities in terms of their types and scales, as well as energy management and control of power systems. This achieves bidirectional energy transmission and use. These transformations require real-time, safe, and stable smart grids with large capacity and high speed. Smart grid has different requirements for security and reliability, network bandwidth, and latency. These are the key drivers. What are the various requirements from the smart grid? Through 5G technology, wide coverage, high bandwidth, and massive connections. It has to support. Coming to the another 5G technology based future is smart manufacturing. This smart manufacturing also through 5G, it is made to revolutionize. Worldwide will invest $900 billion per year until 2020 in Industry 4.0 technologies, with most spent on sensors, connectivity, and software. The investment is expected to deliver annual cost of 3.6 and annual revenue growth of 2.9%. Cumulatively, over 5 years, since there won't be any change, industry transformation requires the demand in manufacturing, super efficient supply chain, logistics operation, the emergency of data marketplace, the provision of new services through this smart manufacturing. What are the various smart manufacturing wireless networks requirement? Employees and machines needs to be connected anytime, anywhere. There should be less latency, less speed. Connection density and coverage should be made wider. Availability and reliability also should be extremely important. And security, it should be highly secured, protected by experts. The another field where this 5G is focused is the mobile health. Humanity is realizing the potential and e-health to increase the availability of medical services and to reduce the cost of delivering them. According to Grandview Research Report, mHealth market scale will expect $49 billion by 2020. Mobile devices are now being used as part of medical diagnosis or treatment all over the world. In mHealth, the wireless networks, when they deployed, these are the following requirements. There should be wireless networking, and then there should be less latency, good speed, and the good coverage. So I think these are the different domains wherein the 5G communication can be focused. Coming to the conclusion, it is the deployment of 5G technology is just beginning. Countries around the world are striving to be the first to market with 5G technologies and services to capture the bulk of the economic benefits from this new technology. So these are the references I made, and thank you. Yes, sir.
Yeah, thank you very much, madam.
Yes, sir.
Yeah, once again, we are so thankful to Dr. Poornima madam, Professor, Department of E&CE, SVCE. In fact, we got a wonderful information regarding the 5G establishment and the evolution and the future scope of the 5G. On behalf of Department of E&CE, once again, we are thanking you, madam. And also, we like to thank all the participants for your active response, and I request all the participants to join for the tomorrow session also. Once again, thank you very much on behalf of the organizing committee, all the participants and the resource person. So we're going to wind up the session today. Please subscribe our channel, like, and click the bell button so that you'll get the notifications. Thank you, madam. Thank you once again. Thank you all.
Thank you, sir.